Okay, so today we're going to talk about an arithmetic sequence. Yesterday we talked about a geometric sequence. Before we get started here, a sequence is just a list of numbers in a specific order, and each one of the numbers in the order is called a term. But before we look at our problems for today, we're going to go back and look at a homework problem from yesterday, because a lot of people that have done the homework have missed this one. What is the A5 of the sequence? Can you tell me from the formula what the first number in the sequence is? The first number in the sequence is the 3. Can you tell me what the multiplier is from the formula? So 3 times 4, the next number in the pattern would be 12. 1, 2, 3, 4, 5. I'm looking for this 5th number in the pattern. And I'm going to skip to the 5th number in the pattern without multiplying by 4 over and over again. I could get there that way. The n in the formula is 5. That's what a to the 5th means. Now, you see how this says n minus 1? If n is 5, what is 5 minus 1? And so this will be raised to the 4th power. Whatever this is, this one is 1 less, because that's what it tells me in the formula. So, to get that answer, I would use my calculator, my Desmos, and do 3 times 4 raised to the 4th power. The 5th number in this sequence down here would be 768. This is a geometric sequence because you multiply to get to the next number in the pattern. And you would keep multiplying by 4 over and over again. Here is another pattern from our homework. If it is a geometric pattern, it has a common ratio. So I take the last number in the pattern and divide by the number in front of it. And the last number in the pattern and divide by the number in front of it to find out if it has a common ratio. 25 divided by 20 is 1.25. 1.333 repeating. Is that the same number? It's not a multiplication pattern. We could also figure it out this way. 5 times 2 is 10. Is 10 times 2 15? No. This is not a multiplication pattern. This is not geometric. Geometric means it's a multiplication pattern. I mentioned yesterday, and we're going to talk more specifically, an arithmetic pattern is when you add to get to the next number. What would I add to go from 5 to 10? And is this a pattern of repeatedly adding the same number? Then that means this is an arithmetic pattern. Geometric pattern is when you multiply to get to the next number. Arithmetic is when you add to get to the next number. Those were some questions I had yesterday about some of the homework problems. Well, let's look at patterns. Can you figure out the next number in this pattern? 3, 5, 7, 9. And the next one is? How did I figure that out? What are we doing each time to get to the next number in the pattern? This number that we're adding over and over again is called the common difference. In math, the word difference means subtract. If I'm adding it each time, why am I calling it the common difference instead of the common adder? Well, remember your fact families from back there in elementary school? You add 2 to get to the next number, or you can subtract 2 to get to the previous number. So it's two ways to look at the same thing. I am repeatedly adding a number, so this is an arithmetic sequence. What's the next number? 1, 4, 7, 10. What comes next? The pattern is adding 3, so the next number would be 13. We're adding 3. We're adding over and over again. That is an arithmetic sequence. The next number in the pattern, what would that be? What are we adding each time? This number is called the common difference. The next number in the pattern would be, and what kind of pattern is this? It's an arithmetic pattern if you add the same number over and over and over again. By the way, when you add the same number over and over and over again, that number can also be called the rate of change. Do we remember another word for the rate of change? Do you remember that the rate of the change could be called slope? And so this is also a linear pattern. Okay, is this an adding pattern? Is it plus 5 every time? This pattern is a multiplication pattern. So what's the next number in the pattern going to be? And if you multiply to get to the next number in the pattern, that's called a geometric sequence. That's the kind we were looking at yesterday. This is the arithmetic sequence formula. So let's see how to use it in a problem. Here we have a pattern. What is the first number in my pattern? That is the A1. The common difference is the number that you add each time to get to the next one. It's called a difference because you can find that number by taking the 21 and subtracting the number in front of it, or taking the 15 and subtracting the number in front of it, or 9 minus the number in front of it. What do I get each time? The common difference is 6. It's common because I got that every single time I subtracted. So this is 6. So now I need to fill in the formula. And so the A1 is 3. and the D is 6. And when you have a number outside of the parentheses, you can distribute that. I'm going to distribute the 6 and combine like terms. So A sub n is 3 plus 6n minus 6. And this number are like terms. So A sub n is 6n, a positive 3 and a negative 6. It's got different letters in it, but do you recognize this has the y equals the mx plus b form? This is actually a linear equation, and that's the slope, and that's the y-intercept. So this ties in with something we're already supposed to know how to do. So we have a sequence, and what's the first number in the sequence? Do you see that these numbers are going down? See that? That means my common difference is going to be a negative number. I'm adding a negative number to make it go down. So you take the last number and you subtract the number in front of it. Do you remember that minus a minus makes a? Or you take the negative 6 and subtract the number in front of it. And do you remember that minus a minus makes a plus? So my common difference number is a negative 5. So A1, my pattern starts with a 4. And my common difference is a negative 5. When you have the number outside of a parentheses, you can distribute that number. N times a negative 5 would be a negative 5n. Negative times a negative would make a positive 5. Combine like terms. And you can also write the equation basically in y equals mx plus b form. First number in our pattern. What am I doing to get to the next number in the pattern? You can find that number if it is not obvious to you. You can find that number by taking the last number in the pattern and subtracting the number in front of it, or taking the 11 and subtracting the number in front of it. Now, this n in my pattern is going to be the number that it tells me to look for. It's not asking me to look for the number 35. It's asking me if I kept finding numbers all the way down to the 35th number in the pattern, this one being 1, 2, 3, 4, all the way down to number 35, what number would that be in this pattern? And that's where we're going to follow the formula. We start with the first term, The n is the 35 that it gave me in the problem, and the d was a 4 in this problem. Now, you can put it into Desmos or your calculator just like that, or you can do 35 minus 1 in your head and put it in like that. Either way, you're going to multiply it out. 3 plus 35 times 4. And the 35th number in the pattern is going to be, is that what you got? You just fill in the pattern. Fill in the formula, calculate the 35th number in the pattern. Find the 125th term in this pattern. Well, what do we start with? What are you adding to get to the next number in the pattern? If you can't see that, you can take the last number, subtract by the number in front of it to find the common difference. Subtract the number in front of it, the common difference is 2. I'm adding 2 each time. And it tells me in the problem to find the 125th number in the pattern. And then I'm going to fill these numbers in to this formula right here. It says A1. Right over here, I figured out that was a 5. Says N, I figured out right here, that's 125. And the common difference, the D number, is right here. You can put it in your calculator, just like that. Or you can do 125 minus 1 and put it in your calculator like that. Whichever is easiest for you. So 5 plus 124 times 2. If I continue this pattern all the way out to the 125th number in the pattern, that number would be 253. Did you multiply and get that number? You didn't subtract the 1. Is that what you... the pattern has n minus 1. This number right here is not 125. It's 124. Okay, would you please copy these definitions into your notes and then start on your assignment?